So we are having next talk at 3:15. So until then, so next talk is time series battle. Until then, if you have any questions, you can get in contact with Ajinkya.
Manoj Kumar Gupta, who is going to be speaking about time series battle Prometheus versus Victoria Metrics for Telco.
And we also have Deepak.
Oh yeah, Deepak Sreenivas along with him. Sorry.
Thank you. Yeah, hi. So let's start and let me introduce myself. Hi, I am Manoj Kumar Gupta. I am a senior principal software engineer working for Red Hat India.
Hello. Yeah, I am Deepak Sreenivas. We come from the same team. I work in product management for the same set of products.
Thank you. And the topic today is time series battle. Sounds like a battle? Yep. And between whom? Prometheus and Victoria Metrics. So what are we going to cover? As we are saying, we are planning to show you our experience sharing, users insights of these two technology solutions, that how they work in the context of high cardinality metrics monitoring, and especially from the telco use case. And that's where on the next slide we will start with that why we are talking about telco here. Maybe it's not moving. Yeah, okay. So the first question comes that what exactly we are referring when we are saying that there is a need of special observability strategy for telco. What makes it so special? So this is where, if you notice the first point when we say 5G networks, it's by inherent, it is having a complex architecture because it consists of RAN, radio access network layer, it consists of core network, and then the edge side, the UE side. All this computing infrastructure, monitoring, and optimizing the system requires a comprehensive solution. But why is it so? Any system you ask, any financial industry, anywhere, somebody say, I have something to manage, right? But what makes it more special is this one. 5G networks, because of this complex architecture, and then you have various sources of information or metrics as we call it. So network device, application, user device, everything of this is generating metrics. And this makes it actually a very large volume metrics data. Now efficiently processing and analyzing this is very crucial. Why? Because telco is all about network performance and reliability, right? And that's where the third point comes. When we say 5G, the main use case we have been told that, okay, yeah, it is generally used for low latency and high reliability for mission critical application like on your workshop floor or any real-time monitoring is using 5G. Now, what makes it so complex is the 5G networks, then the expectation is that you are monitoring the metrics in real time. That means you are able to query them faster, and then you are able to take action based on that metrics. To take an example, let's say we are monitoring a user device for a data throughput. Simple example, right? So you are saying I have to monitor a particular UE as a user endpoint, and in the network I want to trace it to give it either a better QoS or to just monitor it. So this you can see, as soon as I'm telling you this, you can understand that the call flow is from edge to core to RAN, and then it is generating a data which is hitting many network elements, and then you need to have a faster query on that UE so that you can take appropriate action. So all this makes case for a situation where we are saying that just any observability strategy will not work. You need to have a solution which is capable of handling all these parameters or all this complexity. So that's where, if we go further into this mode, Deepak will talk about like what exactly makes the telco more complex here.
Okay. Yeah, so as Manoj touched upon, we are going to see some of the very unique characteristics of telco requirement on a cloud. So basically, what kind of observability and why it's so different when it comes to telco. So there are a few points here. Basically, if you see log storage, for example. So log storage, operators, they demand for kind of a very long-term log storage when compared to other use cases. They need log storages as per, either it could be because of regulatory or maybe to do kind of, inspection, lawful interception. So they're kind of use cases where operators are forced or advised to store logs for a long time. So this brings in a very unique case where you need to have these logs stored on long term. So you have to choose between how you retain the logs or you rotate the logs for how much long. And so that's why you require a lot of how you compress the logs and store. So this is one kind of a characteristic. And there's something called, at least in 5G, right from 4G to 5G, there has been a feedback loop, kind of a closed feedback loop, which operators, they depend upon. So there could be some event which happens in one part of the network, in a RAN, and you have to take the action in the core. It happens for end-to-end use cases like, network slicing, or you have an end-to-end network. There could be an event somewhere and action has to be taken somewhere. So, and this action has to be taken in a real time. So these characteristics, it demands that you observe in a real time and you give the closed feedback in a real time. So that's where this real-time orchestration with a continuous metrics feedback comes into picture. And and when there are events which demands you scale out some some capabilities in your network. Basically, you have this HPA and VPA. I think most of you are familiar with horizontal pod auto scaling and also vertical pod auto scaling, which is picked up. So these they depend on some of the custom metrics. There could be some infra metrics like CPU, memory, and disk operations. Whenever it goes high, you tend to scale out some things. It also depends on some of the custom metrics which are driven from a telco perspective. Calls per sec, some call failures, some signaling handling capabilities. So these are some custom metrics which are demanded by operators, which can scale out and scale in depending on how this performs. And we have a hierarchical and distributed management. Every operator builds its own CRM. And below the CRM, you have this NMS and EMS of operators coming in. So the granularity of these metrics and the interfaces is something which makes it special. So the CRM or the platform of the operator will collect all these metrics from different NMS or EMS. So there's northbound with to support different northbound interfaces is one of the requirements of many operators. And I think I covered regulatory compliances. You need to store all the logs for a longer time so that you enable some lawful interception on these logs. So this is one of the many countries ask for this kind of regulatory compliances, where you need to store audit logs and also the security logs with high preservation times, maybe 6 months or 1 year. So this is something which is important. And granularity. With 5G and going further 6G, what has increased is the number of parameters. For example, only RAN itself has some 4,000 to 5,000 parameters which can be configured. And at least, even if you take 10% or even 20% of those which generate metrics, which needs to be monitored, it's thousands of parameters. So that is the level of granularity we are facing a problem with telco operators. And that's how you require a kind of a scaling solution which can address this. So these are very key characteristics of the telco operators. Next slide.
So then question comes, if data is so granular, so much volume is being generated, so the main characteristic if you could derive by now is you need a very efficient writing mechanism because data is coming with velocity, right, and with variety. And then you need a faster query mechanism because you want the action on that to be taken, right? So this is where when we started this product, so we were originally using Zabbix, the framework. But as you will come to know immediately, all these parameters from 3G to 4G to 5G, suddenly Zabbix starts failing you, right? So that's where we started with, we chosen this option of Prometheus, because as you know in industry, this is a very good open source monitoring and alerting tool, right? Nothing to be more say about it. Those who are aware about this, it is a primary, very popular tool, especially in Kubernetes world, the de facto monitoring. And then it is specialized for time series data analysis, which suits our telco use case, right? And then as per the documentation, it is scalable, reliable, and allowing it to handle large amount of data, right? And then it supports a PromQL, which is a very effective query mechanism to read data, read metrics, and take action. all rosy picture, right? So what's the problem? So I think problem when we took this solution was not there. That's where we are saying that we chosen Prometheus because it was ticking all our checkboxes to be taken as a solution, and then we started implementing it. But then, as it turns out, on the next slide, Deepak is going to explain that this scalable and reliable, this third axis, started breaking for us and became a challenge. What was that challenge? So that's the topic for next slide.
Okay, so yeah, we faced a situation, and so we have a situation. So this is the high cardinality or a high churn and a high churn challenge, which happens in 5G. As I mentioned, the sheer amount of parameters and the metrics which we monitor, so that brings in a kind of massive telemetry data from various network elements, from multiple edges, multiple sensors and devices which are 5G end devices. So they of course bring a wealth of information about the network performance, user behavior, and the operator wants to monitor almost everything so that he can take actions upon. So this is the high cardinality of labels. Labels are nothing but what you give in the queries of Prometheus. You give multiple labels such as, for example, subscriber IDs, location types, device types, service types. So this leads into a very a heavy query with a lot of labels, and this, when the labels keeps changing, for example, if you're tracking some 10 subscribers moving from one radio to another radio end device, we'll have a lot of churn in labels. So you keep changing the label values and you keep querying. So this brings in a high amount of stress on this the solution which are using. So yeah, so this is something which doesn't seem to go with the memory and scalability for Prometheus. So this high cardinality nature of 5G, it brings in challenges for Prometheus in terms of both memory usage and scalability. So that's a kind of summary we have written here. Like, it's a high churn with high cardinality, which is a challenge for Prometheus, especially in a 5G network scenario, end-to-end monitoring.
Yeah, so this is where the problem was, that we are saying that we started with a solution choice, assuming or given that it is meant for this, but then it was breaking because of the limit, because of the high amount of data. For example, this is our one of the run which shows the Prometheus memory footprint problem. What is it showing? We are saying that we run this comparison with only 200K series with 8 level every minute. So this is a very moderate data if I compare it with the right now running any telco live customer data. This is a moderate amount of data, and you can see that the fluctuation in Prometheus memory is from 17 to 20. Technically, if you can ask me what is the problem, 70 to 20 means you can specify a pod limit as 20 GB or 25 GB, right? But then problem really is it is not a constant data, because as Deepak highlighted, the traffic or the churn of data is increasing in the network. So is this memory increasing continuously. So question becomes, where do you stop? What memory limit we specify? Because in our experiment we tried with 30 GB, then after one day it will go overshoot, then 40 GB, right? So it's like continuously increasing. And that's where we noticed that Prometheus was facing the significant challenge when dealing with this kind of data, which is continuously increasing, and that's where the exponential increase in the memory usage was noticed. So anybody in this room who is familiar with this problem, that you have also faced this, or it is not being monitored? So this is the point. And then what happens? Because this happens, so obviously the query latency is increasing, so our read time is increasing. Then you have a resource intensive operation, so even Prometheus pods getting killed due to out of memory. So those kind of issues started reported from the setups. Then question is what we could have done, or what we can do. Prometheus, if you check, they suggest few optimizations like this. That why don't you drop some labels from some metrics? Why don't you drop metrics itself? That means reduce the data to be monitored, scrap what you need, don't do unnecessary. And the third point also, that whichever metrics are very high running, maybe you can split them. So for example, instead of 3 variables in one matrix, you make it 2 variables and then 2 variables in second, and that's how you try to combine it. Okay, very well, let's do that. Is it going to solve the problem permanently? Is it re-engineering or is it a patch? So I think you can agree, right? Whatever I do, today it is okay, I can control it tomorrow, right? Network is going to increase. So we can understand that this is not really a scalable approach to solve this problem permanently. That's where we explored few solutions, what else exists in the ecosystem, and that's where we said, okay, let's try VictoriaMetrics. And that's where we got introduced to VictoriaMetrics, and that's where on the next slide I show you one more comparison before we jump into whether VictoriaMetrics is really the solution. Okay, so in this you can see the comparison between Prometheus and Victoria. This is like a trial run because we want to try, so we took Victoria, we fed the same amount of data, as you can see here, same data was fed under heavy load, and we saw that VictoriaMetrics, the first row is taking 1 GB of memory, whereas Prometheus showed 25 gig. Wow, 25 time difference, amazing. Our data, this was one particular case, but in general, when we tried with a different varying level of queries, it boils down to about 5 to 7 times less memory footprint. So 25 is like for this particular set of data, but in general, if you check even their documentation of the thing, this fact is there that it is 5 to 7 times less memory footprint compared to this. And more specifically, as we will show later, it is not increasing in the same exponential ratio. So that's where we noticed that maybe VictoriaMetrics is a very good solution for high cardinality metrics with lower memory usage than Prometheus. So with the trials completed, that's where we jumped into more details to check whether can we go this route. And that's where now Deepak will say that is really a scalable solution, or is it also suffering from some limitations?
Yeah, this is just to summarize our investigations. So is VictoriaMetrics a scalable solution? Yeah, it's a time series database by itself, and it's designed, of course, to handle high ingestion and high cardinality rate data. Okay, and it's a comprehensive monitoring solution for various applications and systems. These are the definitions of VictoriaMetrics you find everywhere. But yeah, is it efficient and scalable for our purpose? So does it basically for a large scale deployment as of end-to-end 5G network, is it really efficient and scalable? This is what we try to investigate going further. And also, is it cost effective? So, you know, the design of VictoriaMetrics, of course, emphasis on cost effectiveness. You will see how it reduces the memory consumption, the RAM consumption, how it reduces, and also stress upon a kind of a disk usage, how it shifts from a memory to a disk usage, and how efficiently it does. This is what we would investigate going further. So this is where we are.
So cost effective in terms actually implies, because if you're using less memory for the same work, less disk for the same work of storage, obviously you can say that I need less resources, so cost is automatically going down, right? And that's where, if you see, let's start with a simple architecture diagram, not too complex it with various options of Victoria, because I think those who are working with Prometheus, you are already aware about that architecture. So this is fairly simple and straightforward architecture. To start with, for example, any workload, node, port, service, whichever you want to monitor, you are scrapping the data like Prometheus. So the component which is called is VM agent. This is responsible for scrapping and giving you collecting the metrics. It is giving it to VM insert so that it is ready for storage, long-term storage. That's the storage component. And then when you want to query from either Grafana or any other query engine, you are passing this query to VM select, and that purpose is to read the data from storage. So one end you are writing, other end you are reading, right? So then question comes, where is the optimization, or how Victoria become a better choice? So that's the purpose of our next topic, that where is the difference?
Yeah, I think we have few theoretical comparisons as of now. So the first is high cardinality. High cardinality, just to recap, more number of labels you get, tremendous number of labels per query. So does it, and what kind of use cases in telco gets that? We have listed some typical queries in a telco use case. For example, network slice monitoring. Network slice is nothing but it's a kind of a VPN given in a 4G, 5G network, where for each subscriber you get a kind of is one VPN, and therefore each VPN will kind of multiply the number of parameters you need to monitor to sustain that, that SLA which you have given for this network slice. And also per subscriber, each subscriber, his own usage parameters, U analytics, each user end equipment. User end equipment just multiplies in a 5G network with a lot of user end equipments coming in, and how you analyze them with their own specific parameters. And of course, you have core network and transport network also coming from the legacy networks, even if you still use. And they bring their own number of parameters. As I told you, there are around 5,000 to 10,000 parameters which could influence the queries in such cases. So having these particular use cases, we have just factored out some perspective of how Prometheus and VictoriaMetrics will differ. Storage model, I think those have used Prometheus. The Prometheus storage is all, it's based on a block-based storage. So you write into memory as blocks, and also you do a val write. You write ahead logs; those go in a time-specific manner to the disk. And in fact, you write it around 2 or 3 times val operations happen for Prometheus, just to keep it as a HA redundancy. So this increases the storage capacity, memory requirements. While in VictoriaMetrics, you depend on something called LSM. It's a log structured merge tree. This is nothing but these are it's a advanced it's a next step of a balanced tree like AVL tree or a red black tree. You make a tree. Basically, the data structures will influence. Data structures and algorithm is what influencing VictoriaMetrics better operation results. So you have these trees which will make appending and inserting and reading more optimized. Similarly with metadata indexing. Metadata is nothing but again your labels which you query the trees. So you store Prometheus usually stores them in RAM. So with more number of labels, you're increasing your RAM storage. While VictoriaMetrics, you compress them and you write them to the disk as and when it keeps coming. And you also use something called reversed index, where you interchange the labels. You interchange the labels and what data you get. So that kind of a retrieval increases the the performance. And memory usage for labels, I think I covered. It's lower due to in-disk storage of VictoriaMetrics. Data retrieval is slower and it's faster due to this again optimized indexing and retention strategy. Since here it uses a block compaction. Block compaction means there's a spike in disks whenever you do I/O, while VictoriaMetrics is more efficient. It avoids compaction for recently used data so that you can get the data without compaction. So basically, to summarize, for high-cardinality telco workloads, you have this VictoriaMetrics as a better choice here.
There's a question from the audience.
Is it okay if I ask a question now?
Yeah.
So how can metadata storage be just on disk? Don't you need the labels to assign to the data before you store it? So how does that? I don't understand how that would work.
Yeah. Metadata is nothing but labels, right? You use labels.
Yeah, exactly. But when you store the data, you need to kind of map the labels to the data, right? But if you have that only on disk, how do you do that?
No. You of course you map them. It's not only on disk. You map them. The recently used data will be in your memory.
Yeah, but that means the metadata is in memory, right?
Yeah.
Because it says here memory usage for labels high in Prometheus and low due to on-disk metadata storage.
Maybe I'll cover in the next slide because metadata bloat, how Victoria is handling better. That's
okay.
the
There's
question.
a parameter called metadata bloat. Yeah, I think
yeah.
it will be covered.
Thank you.
Yeah, the next slide. Yeah. You're covering.
Yeah. Okay, so I think let's start with that
one more
question only.
question.
No problem.
I had one question
Please.
related to the similar thing. So it's mentioned. Can you go to the previous slide? Yeah, there. It says on disk lower due to on disk memory usage for label or lower due to on disk memory metadata storage. So will this not cause an issue with the memory usage for label wine, the VictoriaMetrics?
Okay.
The third point. Will that
Let's
not
take
cause?
this question and
Okay.
another 2 slide, if it is not clarifying, then we have an action. Right? Okay. So I take that question here. Storage overhead for, so what Deepak mentioned was high cardinality, how it impacts the choice. I'm trying to evaluate it on other parameter, storage. How storage is handled well, because that's where we were talking memory footprint reduce and storage should reduce, right? So here you see Prometheus suffers from a problem called metadata blot. Now what is that metadata blot? See, it's trying to say, for example, let's say we are monitoring a stock price. And because it is time series, so you are monitoring it per second. That what is the price of the stock at this second. And then market is open for, let's say, 10 hours. Right? So 10 hours into seconds. Fine? So this much amount of metrics we have collected. Correct? Now for this each of metrics, Prometheus is also trying to store, okay, what was the stock name? That was the one key value pair, right? What timestamp and what price and maybe who bought it or who sold it. All this data is metadata for that series because ultimately what you need is a stock price at a given time. So Prometheus is maintaining this metadata also with it, and that's where many cases it has been observed that this becomes too much compared to the actual data. This is called as metadata blot. Now VictoriaMetrics started with this principal problem already known. So they try to attack this differently. And they said, okay, let's do it using optimized indexing. So this is where log structure merge is one data structure they used. And second one is label encoding. And third is inverted indexing. So what is this concept broadly are telling? So log structured merge, if you check, it's a data type where they are saying, let's not write onto the disk unless we have something, a good enough chunk. So that means you are trying to write any event coming first in RAM itself, memory itself. So that concept called mem table. It uses a concept called mem table that you build a write buffer in first RAM and then you transfer it to the disk, but differently from Prometheus because that is called as sorted string table. So the data is already sorted, then you are creating a table, then trying to write it. What is the advantage? Data is already sorted when you wrote, so that means your query is already due for fast retrieval, right? Second, when you are writing it, can I optimize it? How do I remove this metadata? That is where this label encoding comes into picture. So what was the label? Name of the company, right? So it's a character string. Can I encode it to a binary number or a octal number or a hexadecimal number? So that is label encoding. So you store all the key values pair like a dictionary, and from that dictionary there is a binary number mapping. This is what you are storing. So you actually reduce the data size of the data actually being written.
So you're not talking about the hashing, you're talking about like an ID type.
ID typing, right? Now this question becomes like, how do you retrieve it? So you need a kind of filtering, hashing. That I go to indexing, then I know, okay, this is my key value pair which I have to show to user. So that's how VictoriaMetrics approach this problem differently, right? So this makes it first 2 points that because you are using label encoding, so you have removed the metadata blot. So your time series data is actually very efficient now, and that's where compression of 70 to 90% is seen. Because now it's like all the texts are gone and you are trying to encode it more binary kind, encoded kind. So this is first. And then same because you have compressed it, so your disk efficiency is already 5 to 10 times more because you are writing less data, right? So less data is writing, so faster you are writing, right? Faster you are writing, so your disk IO is reduced, means both cases, right? You are writing less and you are writing less frequently also compared to Prometheus. So this is where it handles the high churn time series with low input output and optimized for frequent writes, right? And then long-term storage, yeah, you are storing 1 terabyte of data in Prometheus, then because of label encoding, it's already in some GBs, so ultimately you are saving money on the storage disk. Even if you are in AWS, you need less storage. Make sense? And that's where, if we need efficient long-term storage, reduce disk usage and low-cost retention, VictoriaMetrics is providing you a use case for users. Now comes the third element of, let's move to the slide, query performance, because this is for reading time. Will it serve my feedback loop also faster? So that's the answer.
Yeah, I think as Manoj covered, you store as SS tables even in the hard disk. So it's already sorted as a sorted data structure, and you use a kind of binary search if you go to the disk to retrieve it. And if it's still in the memory, it will be in a tree structure. So again, it's it's a balanced tree. It's sorted and it's easy to retrieve, both in memory and also in hard disk. So all this, okay, I have a 5-minute note. Yeah, this maybe I'll just summarize. So it's the same points here, but the last 2 slides we saw while writing how it's efficient. This is the same because they're stored in a read efficient manner, already sorted in both hard disk and also in in memory. So your read performance is quite faster.
Right.
Go next slide.
So this, okay. So this is a summary of the benefit which so far discussed. So for example, we said that it is saving you cost because footprint of both memory and disk is going to be low. So it ultimately results in less resource need, so less dollars, right? And then unmatched scalability and performance. So as we said, the algorithms chosen are like this, that you give it more data, it is not growing exponentially like Prometheus. It is trying to flatten the curve, and that's the main advantage that we can say it is scalable solution as per our experience. And then PromQL, because Prometheus, one popular region is PromQL, query language. So by default, VictoriaMetrics is backward compatible with PromQL, so your existing queries will work as it is. Otherwise, Victoria has a metric QL as its own language, but that is backward compatible. So that solves the compatibility issue. And this makes it very enhanced observability solution for 5G. That's what we are using now. And it's a future proof because scalable architecture is undergoing development. So all this makes it scalable. Then question is it everything rosy with Victoria? Right? Generally not. We have a scope of improvement, and that's where a few parameters you need to keep in mind as a takeaway. It's a smaller community compared to Prometheus, so that means your bug fix cycle or other things are impacted. And then second point, advanced feature gap. So if you are using, suppose other than Prometheus anything, and you are using any advanced feature, VictoriaMetrics may not have that feature, so you have to analyze that are you using any specific feature. And then as we are saying, we did a benchmarking to decide this as a solution. You should also do a benchmarking for your data because results can vary based on your time series data, how you are monitoring. So we request you that you should first benchmark before you adopt this. And then migration complexity. Prometheus to this was easy, but if you are using different monitoring solution, maybe you will face some migration complexity. For example, PromQL compatibility is there or not for you. That will define this choice. So these are some pitfalls to be taken into consideration. And then we move to conclusion.
Okay. So what we conclude and take back home. So let's choose the right solution for our needs of observability. So VictoriaMetrics, of course, is a strong vendor coming up. It's an alternate, which brings in dimensioning, basically the ingestion and the query rate, which into it for various parameters. So it's a strong contender, and yeah, it suits very particularly for a high cardinality use cases where labels are changing on the fly with multiple labels, with a magnitude of 5G end-to-end telco network. So there, well, Prometheus may struggle, VictoriaMetrics might perform better. So basically, you choose, you tailor the solution as per the needs of your domain, the use cases, and of course, it requires a practical evaluation. Practical evaluation, which we have done, we have shown how memory, I think Manoj gave an example of 1 GB versus 8 GB kind of a case. If you observe closely, there is a slight bit of CPU increase, which VictoriaMetrics consumes, but it's a milli CPUs. So that could be negligible, but for those use cases which are requiring for a tailored kind of use case, if CPU is a contender, even a small milli CPU, then of course you can still evaluate between Prometheus and VictoriaMetrics.
Yeah.
So having said this.
So I think if any questions are there, we can come to in a moment. Before that, I think we also kept one data from our live cluster, in fact lab cluster, to show you what numbers we are talking about. So for us, as you see in Prometheus, 2 hours block duration, because the TSDB is of 2-hour block, the 4.2 million is the total series count. And if you combine with the labels, so this is where you last see 32 million is the posting entries. This is from the lab. If I convert it to a live production with large number of nodes and other things, this data is going to be more. That's where our challenge in Prometheus was coming for this kind of scale. Just to illustrate. Now we are open for any last 1 or 2 questions. Yeah, please. Yeah.
Did you evaluate Thanos because it works with existing Prometheus
Yeah, so I think Deepak showed that the parameters for high query was with Thanos. If you see here, we said that you can use Thanos as object storage, but if you really understand what is Thanos doing, it is running at a sidecar with you in your Prometheus, and you are saying that I will take the data and write it.
And
What problem of Prometheus it is solving? Is it reducing the footprint of memory? Is it again a scalable solution?
And one more aspect is we are using a telco use case, and on-premise storage is very important for us. Thanos usually depends on other storage,
Other
like
storage, yeah.
AWS S3 or GC Cloud, Google Cloud. So we wanted VictoriaMetrics in that way uses your own disks.
So that was one point. The other thing is some Prometheus is front end and VictoriaMetrics as a back end. And then because of this high RAM usage, we are slowly shifting to VM agent as a front end. So if you can see what we are changing, these two altogether different ecosystem. Because what we are changing, we are trying to work around the Prometheus integration by saying data distribute the database, introduce dummies, introduce in fact remote API we can write to Victoria metrics in Prometheus, right? But then we are again starting from RAM issues of Prometheus. So that's where we are also migrating now to VM agent base. Then remove altogether Prometheus. Trying to separate VM and prevalent. So that's the message we are trying to convey that there is an alternate ecosystem which can also serve your use case better way. Yeah. That's the message. Yes, please.
And you already use IOPS as well with that solution?
Which one again, sorry?
It's ITSA, ingestions, security features or requirements IOPS.
Sorry, where did anything which database area?
No, just wondering.
No, we are not.
Actually, the observability, anything they would use or require for example, telemetry setup.
See, reporting wise, if you are saying anything, auditing wise, when you are changing, it's not impacting because ultimately the retention period is what it is governing and your payment mechanism, right? What you want to audit is outside the purview of this. The purview becomes the full part, right? And the alert monitoring part.
Thank you.
Any last question?
How is European use case
Moving to Victoria, yeah. For simpler use cases, you mentioned about high-cardinality link, 5G use cases. But for a simpler use case, do you still recommend switching to with Prometheus or just ambient option? So I think let's be clear. We did not say Prometheus is bad, right? We ourselves adopted Prometheus, but it is a de facto standard in the industry. But what we are saying is our use case of high, when you start getting more data and more data, it is not scalable. So in that context, we have now started the Victoria Metrics by default is not having that problem even for smaller case, and that's why I would like to show you the architecture where it is not that complex that you are introducing altogether complex things. So alternates are there. If your use case is satisfied with everything, you can still continue to work on it. It's not going away.
in terms of how difficult usually to switch over?
Not much difficult. That's what we are saying. Because we started first with more right API of Prometheus. So we introduced storage of metrics first. Prometheus was still in front end. Now in this upcoming version, we are also removing Prometheus and introducing a VM agent. So complete review and writing is in Victoria Metrics only. So it is done in phases. Yeah. So the prompt here, the prompt here is to Telco application metrics will not change. So yes, but the infrastructure level will be changed in the prompts.
Thank you.